Welcome, 7th graders. Time for our Test 19 study guide. 7th grade math, Test 19 study guide number 1. They give us two tables and they say decide which of these tables are proportional. So what we got to do is we have to take all of our y's and put them over our x's and see if we get the same ratio for each one. Now, of course, if we have 0 at all, they should both be zeros for proportional. But they both have that, so that doesn't help us out. So what do? We take all of our y's, put them over our x's, and see if we get the same one. So for the first set of coordinates, we have 1/5 over 1/15, and we're just getting that from our box, right? That's x and that's y. So then I put the y over the x, and we learned this earlier in the year, that all fractions are division problems, and then all division problems can be written as fractions. So what I do is I write 1/15 first, and that's going to be divided by the bottom, the 1/5, the denominator. And the way I divide by fractions is to multiply by reciprocal. I never change the first one. I multiply, flip the second one upside down, and that's when we go to factor trees and cross out our ones, and we get a ratio of 1 to 3. Okay? So when I put y over x, I get a ratio of 1/3. Over here on this side, I get my next set of coordinates for my table. The x is 2/5, the y is 2/10, so that set of coordinates 2/5, comma 2/10. I put the y on top, and I get 2/10 over 2/5, right? The y goes on top, and then that's division, which means I multiply by reciprocal. And at this point, don't multiply first. That's a bad idea. You want to break it down first. Factor first. Cross out your ones first. And remember, if everything crosses out, these two 2's cross out, these two 5's cross out. We only cross out stuff that's on top and on bottom. But if everything crosses out, there's still a 1 up there. 1 doesn't go away unless the 1's on the bottom. So that's a ratio of 1/2. I know that table 1 is not proportional because I didn't get the same ratio for all of them. If you don't get the same ratio for all, it's not proportional. So forget about table 1. Let's take a look at table 2. So for table 2 is a little bit easier. Table 2, they don't give us fractions, okay? Now, it doesn't mean this is not proportional because there's fractions. Don't make that mistake of thinking that. This very well could be proportional, okay? This one, though, we put y over x. That's 1 over 2. 1 over 2 is 1/2. The next set of coordinates is 4/2. We put 2 over 4. That reduces to 1/2. Again, factor trees, cross out your 1's, right? We do that all the time. And for my last set of coordinates, 6/3, we put y over x. 3 over 6 is the same ratio as all the rest, so table 2 is proportional. Now, don't assume that there's always going to be 1. It could be 1, it could be both, it could be neither. So check them both. Don't assume ever. Number 2 says a man charges a proportional fee for a service. For 7 hours, he charges $210. Which fee below would be proportional to his? So what we have to do is we have 3 different rates there. We have the one given to us in the problem, and then we have the 2 fees to check. So we have to go and check the first one given to us. So what we're going to do is remember like that old rap song that doesn't exist that I told you about? Money on top. Got to put the money on top, right? So we put the money on top. So for the problem that they gave us, they said worth this $210. It is for 7 hours, so remember, time goes on the bottom, money on top. And then when I divide those two, I get a ratio. Remember, it goes in and out, right? $30 per hour. So the first fee, we put money on top, and we divide in and out like we learned in class, right? There's the work. If you need to pause the video, always just do that now. Check your work. We get $30 an hour. So we got the same ratio as the problem. Let's check fee 2, though, because it might be both of them, right? When I check fee 2 and I go in and out, I get $40 an hour, so the only one that is proportional to the rate given in the problem is fee number 1. They're both $30 per hour. Going on to problem number 3. Problem number 3 says enter the value of c when the expression 17.5x plus c is equivalent to 3.5 times 5x minus 9.2. Okay, so basically they're saying what goes here when you distribute. They're saying what goes there. That's what it means by find c. So what you have to do is take the expression they give you, the algebraic expression they give you, and then simplify it. In other words, distribute, combine like terms, but in this case we're just going to distribute. We do the rule for subtraction first. Add the opposite. 3.5 times 5x is 17 and 5/10 x, and 3 and 5/10 times negative 9 and 2/10 is negative 32 and 2/10. So what goes here for C? Well, negative 32 and 2/10 goes there. That's the answer to this problem. Number 4 says, find the value for that expression. And that expression they give us has no variables inside. So what we can do is we can go ahead and just simplify the inside first. We can do order of operations. We can do the grouping symbols first, right? Now, we could distribute like we did over here. That's going to work too. But in this case, where they don't give me any letters, any variables, I just go ahead and do 10.5 times 4.5 is 6, right? $10.50, take away $4.50, I have $6 left. 9 times 6 is 54. That's how you do that problem. Number 5, a school teacher asked 4 students to create an expression that would be equivalent to the one they gave us. So they give us this really long expression, okay? And then they gave us 4 students below, and we said, which of the 4 students gave an equivalent expression to this? So basically we have to simplify all 5 expressions, the 4 students and the one given to us in the problem. Do the one given to you in the problem first. So I'm going to go through and do my rule for subtraction, okay? That's an addition problem, so I don't do it there. That's addition. I don't draw 2 sticks, so I don't do my rule for subtraction there, even though that's negative because it's already an addition problem. This is not an addition problem. This is a subtraction problem. That's when I do the rule for subtraction. I draw 2 sticks, I do add the opposite, and now I'm ready to distribute. When I distribute, I multiply the 5 times negative 3x. That gets negative 15x. I multiply the 5 times 7 and 2/10. That gives me 36. And notice that I copied all the other stuff down that I'm not using. Now I'm going to combine like terms. I add my x's to x's and my constants to constants, but I don't add them to each other because they're not like terms. So this is simplified. I distributed, I multiplied, and then I combined like terms. And that's simplified. Now, just remember, when you guys are doing decimals, to line the decimals up, okay? So you should have gotten what I got. So pause the video, make sure you do the work yourself and get the same thing I got. So we simplified this expression. Now we're going to go and check the student. So the first student is Isaac. So Isaac, we had this expression right here. We do the rule for subtraction for Isaac and combine like terms. Only add x's to x's. That one's already done. So when you simplify that, you can see that you get 1 and 25/100 x plus 45 and 8/10. That is not the same as what we got from the problem, so that student didn't provide an equivalent expression. And for those of you that would like to take shortcuts, you know you're only adding x's together, so the constant left is 45 and 8/10. Didn't even need to do that, right? Because my constant's not 45 and 8/10, so I could have just said, oh, there's no way that's going to be the same. Let's take a look at Madeline. Madeline, let's go ahead and simplify it. We'll do the rule for subtraction, add the opposite. We'll combine our like terms. And for the first term, we get negative 21 and 25/100 x times 32 and 5/10. That's equivalent because that's the same expression that we got in the problem itself. So Madeline's good. Let's check Charlie. Do the rule for subtraction. Combine like terms. Now, there's only one x there. These guys aren't x's. These are constants. We add constants to constants. But by the way, look, check. The x right there, 21 and 25/100 x, is the same as our x here in the problem. So it might be good. If it were different, I would stop, right? I wouldn't even finish the problem. I'd say, you know, Charlie didn't work. Sorry, Charlie. But let's check Charlie and see if he does work. So when I add the 2 constants together, they're opposite teams, so I subtract. I say who has more. There are more positives, and I see that this is the same expression. So Charlie's good. Madeline's good. Let's check Chloe. So when I check Chloe here, I see right away, look, there's only this x right here. These guys are constants. So I'm not going to change this x. There's no other x's to combine. I already know it's not equivalent, so let's just take the shortcut this time and say Chloe doesn't work. So how many worked? Well, there was 2 of them, so that's the answer you picked. 2 students provided equivalent expressions. Problem 6 says, which expression below matches the solution for the inequality 6x plus 3 is less than 39. So in other words, we're going to solve this inequality. So we work farthest away from the variable first, doing inverse operations. I do not reverse that inequality unless I divide by a negative or multiply by a negative, so that inequality is always faced the other way. Whatever side my x is on, I leave it on the same side all the way down. And so since x is less than 6, and I could even write this the other way, right? If x was on the other side, the x is still away, the mouth is still away from the x, that's still less than, right? This says 6 is greater than x, but that's the same as x is less than 6. We'll say the variable first. So there's no equal to sign, so that means an open dot, not a closed dot. Less than means the answers are everything smaller than 6, so the arrow goes to the left. Number 7. Morgan had $58 and earned $13 an hour for babysitting. She wants to buy a $350 item. Which is the minimum number of hours she needs to babysit in order to buy the item? Okay, so minimum means it's an inequality. So you think about it. She's got some money, right? She's making some money. She has some money. But all the money she has together, it can be the same as what she spends, or it can be greater than what she spends. In other words, let's see, did I say that correctly? We want to make sure that she makes enough money or more than enough money to get what she wants. I hope I said that correctly earlier. I just said it right just this time, though. So we're going to solve this inequality. In other words, all the money she makes has to be more or equal to what she needs. It can't be the other way around. She can't make less money than what she needs. She wouldn't be able to buy what she wants. So that's why the mouth is eating this side and not the total side this time. So we work farthest away from the variable. We subtract 58. Divide both sides by 13, and when we go in and out, we get about 22.4. And you know what? You can stop right there, because our answers will be greater than or equal to 22 point whatever. But if you think about this, this is one of those situations where you would either always round up or always round down. Let's try to make sense of this. So if the x is, no matter how close to 23 it was, we would never round up. Right? Because we want the minimum amount that she needs. The minimum amount that she would need, the minimum amount she would need would always have to round up here, okay? Because if she works less than 22, even if it was 22.1, if it was rounds down to 22, we would always have to round up because she would never have enough money to make this, right? So it's got to be greater than or equal to 22 point whatever. We're going to round to the nearest hour, so we're going to have to round up to 23 hours, okay? All right, so number 8 says, Emily has $20 to buy tickets. Okay, so here's her total here. She's going to buy some stickers, actually, not tickets. And she's going to buy 8 stickers that are 20 cents each. Now, 0.2 is the same as 0.20. And if she's buying 8 of them, it's times 8. She's also going to buy some 55-cent stickers. We don't know how many. When you don't know something, that's where you assign the variable. That's where the letter goes. We don't know how many stickers, so that's x. But however many there are, we multiply it by 55 cents each, plus the money for the other stickers. That has to be the same as the $20 she needs, okay, or less than that. Because Emily has $20. Okay, this is all she has, right? She can't have less than what she needs. So that's why the mouth's eating the total this time. I know it's confusing because this time the mouth wasn't eating the total, right? Okay. So I guess the way to make that clearer for you is, is it what she has or what she's trying to get? And that could help you decide. If this is all she has, okay, and she's going to spend this much, then what she spends can't be more than what she has. Over here for this last problem, if this is what she's getting, the money she's getting, and that's how much she needs to get, she's got to get more or the same. If this is all she has, she's not getting more, but she's spending, what she has can't be more than what she spends. I hope that helped you. Not sure if that cleared it up for you. But let's try to finish this problem. Number 8 is going to be the same on the test, right? Same idea. So for number 8 on the test, it's going to be the same idea, right? The mouth's going to eat the total this time for number 8. All right, so let's go ahead and simplify this. We got 8 times 0.2, got 1.6. We're going to subtract the constant from both sides. Remember to line your decimals up, right? The decimal's at the end of that 20, okay? So you should get 18.4 when you do that. Go out to the side and fix that. If not, ask me in class tomorrow how to do that. And then we go ahead and divide by the coefficient. Remember, it goes in and out. For the divisor there, I showed the work down here just in case you guys forgot. Move the decimal 2 times, and that's how you get where our answer is less than or equal to 33.4. So no matter what it rounds to mathematically, this is a situation where you always have to round down, right? Because she has money and she's spending money, as opposed to she's making money and she wants a certain amount. So this time we got to round down. So it always round down to 30. We got 33 stickers is the most she can buy, right? round it up, she wouldn't have enough money. So number 9 says Trinity is filling up a tank. So she wants to get 20,000 gallons in the pool. She has picked out started reading the other problem too. She already had 9,000 gallons in the pool. She starts adding water at a rate of 30 gallons per minute. Write an inequality that shows the number of minutes m she can add water without overflowing. Okay, so she doesn't want to overflow. So her total this time, it can be the same as what she pours into it, or the total can be more. Because if she pours in more, if you have the mouth the other way, it's going to overflow. Okay, so these problems, you just have to figure out whether the total should be more or less than the expression. So this is a situation where the total should be more, otherwise the pool will overflow. So again, this one, all they wanted was the expression. So you could have written this the other way around, where the m's on this side and the 20,000 is on this side. Just make sure the mouth is eating the total so we don't overflow. Number 10, each person in the family, so we got 90 to 110 gallons of water being used, 5% for different activities. How much for 3 people? So we got to find 5% of 90. Is over of. Total goes on the bottom. If I'm finding 5% of 90, I put the 90 on the bottom, not on the top. So cross multiply here. 100 times x is 100x. 90 times 5 is 450. Divide by the coefficient. Shortcut for dividing by 100 is move the decimal 2 times. So in other words, 5% of 90 is 4.5. 4.5 gallons are used per person for these different activities. But how much is that for 3? Multiply by 3. So on the low end, 5 gallons. Now we got to find the high end. They say 90 gallons to 110 gallons. So we got to find 5% of 110 now. Because 5% are used for these activities. How much are used for these activities for 3 people? In other words, find 5% of 110. So I find 5% of 110. 5% of 110, I can cross multiply. That's how we solve proportions. 110 times 5 is 550. Divide by 100. Again, when we're lucky enough to divide by 100, we just move the decimal 2 times. So each person is using 5.5 gallons on these various activities. How much for 3? Multiply by 3. That's how you get your rate. 13.5 to 16.5 gallons are used for these different activities for 3 people. So number 11, a proportional line on a graph. So proportional means this, right? Proportional means you already know the equation. It's y equals slope x. That's proportional. There's a shortcut, right? All we need is 1 point, and that's what they give us. They give us 1 point. So we always know money's on top. Money's always y, right? So instead of using y, we'll use c. In gasoline's on x, instead of using x, we'll use g for gasoline. So once they give us 1 point, so our equation is going to be c equals mg. That's a sloppy g. That's a g right there. And the point they give us 4,1 means put y on top. 1 over 4. Simplify your fraction if you can. That's how you get your equation for a proportional line. It's pretty simple. Put y over x. Put that in front of that. And whatever is y goes where the y goes. Number 12. A proportional line on a graph of gasoline. Whoops, I'm sorry. That was 11 again. Number 12 says a woman bought an item for 4.5% sales tax. The tax added $10 to the price. Okay. They said, what was the price of that item before sales tax? Round to the nearest cent if necessary. All right, so we have this proportion right here. And the reason that the 10 went on top and not the bottom this time is because they're not saying that that $10 is 4.5% of some number. They're saying this $10 is the tax. So $10 is 4.5% of something. And they're saying find the original amount. Remember, original always goes on bottom. So is over of or original on bottom, whatever it takes to get you to put it in the right spot. This time the number goes on top. Cross multiply, 100 times 10, put a 0 after 100. 4.5 times x is 4.5x. Divide by coefficient. And so I go in and out. Now we can't just move the decimal this time, right? Because I'm not dividing by base 10. This time my base 10 is inside. So in other words, just go in and out. You get 222 and 2 repeating, rounded to the nearest cent, $222.22. Number 13, the store is having 30% off sale. So 30% off, and they want us to find how much you'll save. So for this, we're going to find 30% of 800. 800 goes on the bottom, cross multiply, and divide. Remember, dividing by 100, move the decimal 2 times. Now, for some of these problems, you have another step. And the way you know you have another step is because they'll ask you, what's the new price? They ask you, what's the new price? You have to subtract this from the old. But they're not asking us that this time. They're asking us how much you're saving, so we're done right there. 14. Write the fraction as a decimal, so we go in and out. Check the division. Make sure you get 7 and 75 hundredths like I did here. Pause the video. Number 15. Which fraction is in between these two? Now, unlike adding and subtracting fractions, we don't need the lowest common denominator. Just take whatever's over here and multiply top and bottom, because if I do it to the top and bottom, I find another fraction that's equivalent to 3/11. Same thing with 1/8. Use that denominator, 11 over 11. Now, 1/8 is the same as 11/88. The reason I do that is because now that it's the same size pieces, I can see which numerator is in the middle, and of all the options they gave me, the only one that's in the middle is 15/88. You just got to get a number in between those two, right? Once you rewrite these equivalent fractions, just get a number in between those two, keep the same bottom number. That's it. 16. How many numbers are equivalent to 4 and 25 hundredths? We're going to convert that first. Okay, so this is read 4 and 25 hundredths, right? I taught you how to read that the right way earlier part of the year, so that now you can write it as a fraction. 25 hundredths is 25 over 100. That's 25 hundredths, another way to write it. Reduce the fraction by doing your factor trees and crossing out your ones. Remember, there's still a 1 up top. When you cross them out, it doesn't become 4 or 0 over 4. It's 1 over 4. So we have 4 and 1/4. Convert that to a improper fraction, or just a fraction. And now we see which of these options are the same. So negative 15 over 4, well, that's got the wrong numerator. Negative 17 over negative 4, well, that has 3 negatives. 3 negatives means it's a negative answer. My answers are positive, so that doesn't work. 4 1/4, yes, I got that. And the opposite of negative 4 1/4, well, 2 negatives is positive, so that's the same. So the last two work, so 2 are equivalent. Number 17. We have this expression here for 17. We've got to simplify. So there's no coefficients in front of these parentheses. So in other words, just add your x's, use teams. There's more positives and negatives. Add your constants. 7 plus 2 is 9. You can't add these two together. Can't add x's to constants, so you're done. Number 18. For that number line for number 18, they don't give us any values here, so this can be kind of tricky, right? So these can be counting by ones, tens. They can be counting by fractions. So what do we do to decide which expressions provided are going to give us certain numbers, right? So the way we do that, we just assign numbers, right? We talked about this in class. Just if they don't give you anything, just call that 1. Then that's 2, that's 3, that's negative 1. Just write the numbers. Rewrite it, putting in these numbers, and now you can answer this question. Okay? So expression 1, a minus b. So if you go down here to the number line we made, a take away b, you got negative 2, take away positive 2, that's negative 4. And the question is asking us which ones equal 0. That doesn't equal 0. That equals negative 4. So check expression 2. A plus b. So if a is negative 2, b is positive 2. Yep, that equals 0. Expression 3. B take away c. Well, we assigned 2 for b and 4 for c. 2 take away 4. Rule for subtraction. Teams gives us negative 2. That doesn't equal 0. That doesn't work. And expression 4. C take away a. That would be 4. Take away a negative. So make sure you put 2 negatives there. Do the rule for subtraction, add the opposite. That gives me 6. That doesn't work. And expression 5, a plus c, that's negative 2 plus 4, which equals 6. That doesn't work. So the only one that works this time is expression 2. Number 19, they give us a scale drawing. If they give us a scale drawing, that means you can write a proportion to solve it. So the scale that they give us is 1 to 7.5. That means 1 over 7.5. And then they give us a drawing that says find x, right? Well, the corresponding sides are 9 and x. The little one is 9, the big one is x. So notice my scale. For my scale, I put little on top, big on the bottom. So for my triangles, do the same. Put the little side on top, big side on the bottom. Now when I cross multiply, 1 times x is 1x. When I cross multiply here, 7.5 times 9 is 7.5 times 9. Whenever you're dealing with any type of fractions, make everything a fraction. Convert 7.5 to 15 halves. Convert 9 to a fraction by putting it over 1. 1 times x simplifies to just x. So my answer is, we got to multiply these two. That means you're going to do factor trees, cross out your 1s. You'll see that there are no 1s to cross out, so we multiply across. X, or my answer, or my length for this side is 135 halves. You could convert that, but you don't have to as long as it is simplified. Alright, so number 20. Number 20, before we do number 20, they give us, they give us some information up here and they give us some graphs, and it's pretty complicated at first. But I'm going to try to break this down, because if you get the concept, it's actually not as difficult as it looks. Here's the concept, okay? We're going to start out with a small graph, and let's say that the next graph is 3 times bigger. And if this next graph is 3 times bigger, in real life, if real life is 50 times bigger than this, we can answer a question. So let's say I start out down here. Let's say I start out with the length of 2. If this is 3 times bigger, I think most of you could answer that would be 6. And if this is 50 times bigger than 6, most of you can just say, well, that would be 300. And that's literally what we're doing. We're taking the first distance, and however many times bigger this is, we'll multiply it to get the next number. And however many times bigger this is, we'll multiply it to get our answer. And that's how big it is in real life. Okay, so that's what we're doing here. The only difference is we got to find out that this is 3 times bigger. They already tell us this is 15 times bigger. And they give us this distance here. So we got to get this first. So that's our goal. How many times bigger is the second map than the first map? That's what we're doing. They tell us how long something is in map B. We have to figure out how many times bigger it is in map A, so we can multiply it, and then multiply it times how many times bigger it is in real life. So this is what we're going to do. In order to figure out how many times bigger map A is than map B, we take 2 corresponding sides. And in the problem, they give us the distance from Riverside to Gladville in both. In map A, that distance from between those 2 cities is 12 centimeters. In map B, the distance is 4. So we got a ratio. We know how many times bigger A is than B. This is 3 times bigger. Okay? Or if we're doing map B first, because usually for these ratios, usually they'll put, it looks like they're going to put the small one first and the big one second, right? So we'll do that. We'll put the small one first, big one second. So we got a 1:3 ratio. In other words, this is 3 times bigger, right? Okay, so next, what we need to do is we need to find the distance from Gladville to Columbus. Okay? So the question says, what is the actual distance from Gladville to Columbus? Okay? So we're going to, Ben, back to that first analogy here. We're going to find how far is Gladville to Columbus from the smaller one. We know that it's 3 times bigger, so we'll multiply it by 3. And then we'll get the ratio, which will be 15 times bigger, to get the actual distance. Okay? So first things first, how far is it from Gladville to Columbus on the small map? So on the small map from Gladville to Columbus, they just flat out tell us. They give it to us. It's written right here. Right? It's written down here. So we know it's 2.5. We figured out that map A is 3 times bigger, so multiply it by 3. So on map A, that distance, even though they don't write it on the map, is 7.5 centimeters. And then, look, in map A, look what they say. 1 centimeter is 50 miles. 1 centimeter is 50 miles. So if 1 centimeter is 50 miles, 7.5 centimeters is 7.5 times 50. Or in other words, 375 miles. Alright, hope that helped you guys out.